So hello students. So in our previous classes we have discussed till the combination reactions. Okay. So what was combination reaction? In where two or more than two products they together combine to form only one product. So that kind of reaction was called combination reaction. So today we will be learning about second type of reaction, that is decomposition reaction. Okay. So from the name itself you can know that what is decomposition. Decomposition means to break down something. Okay, to decompose something means to break down something into their simpler products. Okay, so what is decomposition? It is decomposition means breaking down of anything is known as decomposition of the particular thing. Okay, so decomposition generally means breaking down. Clear? So now what is decomposition reaction? So if anyone asks to define decomposition reaction is a simple reaction in which what happens, a single reactant, it breaks down to give two or more products. Okay, so this is the clear and simple definition of decomposition reaction. Okay, so this is the definition, but the question which arises in your board exam is that they do not ask you generally to define what is decomposition reaction. They will ask you to identify out of the following, out of the given reactions, then which one will be decomposition, which one will be combination reaction. So how you can identify? You can simply identify by seeing that if the number of reactant is 1, okay, and if it is giving more than one product, then we can finally say that that kind of reactions are generally decomposition reaction. Okay, so the first example of decomposition reaction given in your NCERT book is this ferrous sulfate. Okay, so this ferrous sulfate is generally green in color. Okay, so color of ferrous sulfate is green. Okay, and we will take solid form of ferrous sulfate. So ferrous sulfate is a salt. So when I was discussing about the physical state of any given chemical species on a chemical while writing the chemical equation, we have discussed that generally salt exists as solid in decomposition reaction. So in decomposition type of reaction, generally salt always exists as solid. Okay, so this is ferrous sulfate. So when it is generally green in color, and we will hit the crystal of ferrous sulfate. Okay, so what we will hit? We will hit the crystal of ferrous sulfate salt. Okay, so it is green in color. Generally ferrous sulfate does not exist in this formula, it exists in this formula, that is ferrous sulfate heptahydrate. Okay, so you will learn about this what I have written here, that is 7H2. Okay, so what will happen? 7H2, what is 7H2? Now you will think sir has brought up a new formula, what is 7H2. Okay, so ferrous sulfate is itself difficult. Now I am again giving you another formula, that is 7H2, and I am saying that this does not exist as this, it exists as this. So forget about this for the time being. You will come to know about when you will learn about salts. Okay, probably in your second chapter acid basis. So here I think you will get to know about water of crystallization. So this is water of crystallization. Okay, so for the time being you can forget about this. So the color of the salt ferrous sulfate is green in color, and when we will hit them, okay, so this small triangle, okay, so what this small triangle represent? It represents heat. Okay, so in your book it is written as heat. Okay, instead of heat, symbolically we can write this small triangle. Clear? Okay, so instead of writing 4 letters HEAT, we are just drawing a small triangle over the arrow. Okay, simple. So next what will happen? It will decompose. Decompose means it will break down. Okay, to break down to give more than one product. Okay, so this is the first product. Is what is this product? We have already seen this product. That is, this is ferric oxide, and I have already told that oxides of any metal generally exist in its solid form. Okay, so this is solid, and this is sulfur dioxide. This exists as gas, and this is sulfur trioxide. This is also in its gaseous form. Okay, so this is the first example that is given in your book. Okay, and this example you can also use in your endothermic reactions. Okay, in our previous classes we have discussed about endothermic and exothermic reactions. Yes, what are endothermic and exothermic? Endothermic and exothermic reaction. So what were exothermic reactions? Exothermic reactions are the reaction in which heat or energy is produced in the reaction. Okay, and what are endothermic reaction? The reaction in which we provide heat so that the reaction can proceed. So here what we are doing, we are giving heat to ferrous sulfate salt of the crystal of ferrous sulfate so that it decomposes into ferric oxide, sulfur dioxide and sulfur trioxide. So this is an example of endothermic reaction. So remember one thing, all type of decomposition reactions which we do it thermally. Okay, so what thermally and what I have written here thermal and light, that I will explain later on, but just remember the decomposition reaction where heat is used are always all those reactions where heat is used for decomposition are example of endothermic reaction. Clear? So in exam also, suppose in any question if you are asked to give an example of endothermic reaction, you can take out any of the reaction from your decomposition reactions where heat is used and you can write that as an example of endothermic reaction. Clear? Ekdam simple. Now I have written here thermal and light. Okay, so this also has a separate name. This is called photolysis, but forget about that at the higher level classes. So now you will know thermal and light. Why I have written thermal and light? Because there are two ways for decomposition to occur for any given substance. Okay, so thermal means heat. Okay, so if we can use heat to break any of the substances, or we can also use light to break a substance. Okay, so what it is happening in this reaction, that is ferrous sulfate is breaking down to give this product. Okay, so here we are using heat, so this is a thermal decomposition. Okay, and if we use, instead of heat, if you use light, then this is an example of decomposition reaction where light is used to break down the given substance. Clear? So there are two ways of decomposition. We can either use heat or we can use light. Clear? Very clear, very simple, nothing more to learn about this. We will be looking down again few more examples so that your idea of decomposition reactions become easy. But one thing you need to know, that from this particular type of reaction, okay, so generally more than one questions appear in one or the other form. Okay, so they may simply ask you to write to identify the given reactions, or they may also simply ask to, they will give a particular phenomena or particular process and they will ask to write down its chemical formula. Okay, so such type of questions generally appear in the board exam. Okay, class 10 board exam. So we will be looking at some more examples. Okay, now we will be looking at two more examples that is discussed in your book. One is a very common thing. What is this? The chemical name of this is known as calcium carbonate. Okay, so we have discussed about this in our previous class also when we are learning about whitewashing of walls. So we discussed about calcium carbonate. Okay, in your book it is given as limestone. So the limestone also contains calcium carbonate. Okay, but the chemical name of this is not limestone. The chemical name of this is calcium carbonate. Okay, but marble and limestone, both calcium carbonate is present. Okay, so in exam, if it is not given about calcium carbonate, if this name you do not find, calcium carbonate, if it is given that with limestone, when we heat limestone, we get a reaction in which quicklime. So what is this? Quicklime and carbon dioxide is formed, and write the chemical equation. So you have to write this equation only, because limestone also contains calcium carbonate. Okay, so chemical name of this is calcium carbonate, and limestone and marble contains calcium carbonate. Okay, you should be very clear about this. Do not write the chemical name of this as limestone. Okay, so a simple reaction, calcium carbonate. Okay, we are heating it. So we have already discussed that in decomposition reaction, the salt that we use are generally in their solid form. We are heating it, we get calcium oxide, and all metal oxides are solid, and carbon dioxide gas. Simple reaction of decomposition. Okay, and very easy to remember also. Okay, so this can be your topmost example if any such question arises in the exam. Okay, so next is Pb. So what is Pb? Pb is the chemical symbol for lead. Okay, so this is a metal, and PbNO3(2). This is lead nitrate. Okay, this is lead nitrate in its solid state. We are heating it to get lead oxide and nitrogen dioxide. Okay, and oxygen. So one interesting thing what happens during this reaction is, when we heat lead nitrate, we get nitrogen dioxide, and when this nitrogen dioxide come out of this tube as a gas, then the color of nitrogen dioxide is brown. Okay, so when you see that some brown fumes, or what we can say, that some smoky thing, brown smoke will appear. Okay, so these are generally known as fumes, brown fumes, and it is of nitrogen dioxide. Okay, so if anyone does this activity in their lab, so they should try to avoid smelling this brown fumes. Okay, so this can be sometimes poisonous. Okay, so these are the two examples, two more examples that are discussed in your NCERT book, calcium carbonate and lead nitrate. So next we will be looking at one activity and one interesting phenomena also. Okay, so let us see what is the next activity. Okay students, now we are seeing here some diagrams. Okay, and these diagrams represents your activity 1.7 that is given in your book. Okay, so this is an unique thing. Okay, electrolysis of water. Okay, so now you may ask that during decomposition, I have already said that decomposition generally occurs by heat or by light. Okay, but this is another type of decomposition where electricity is used. What's this electrolysis? Electrolysis means if we break any substance. Okay, if we break any substance using electricity, then we can say that this process is known as electrolysis. Okay, so what will it be? Electrolysis of water. That means we will be breaking water by, we will be decomposing water by using electricity. Clear? So that means electrolysis of water. Okay, so first look at this reaction. So what this reaction says, that if water breaks down. Okay, so generally we see in combination reaction what happens, hydrogen and oxygen together form water molecules. Okay, but if we see the reverse reaction, that is if we are breaking down water, then what we will get? Hydrogen gas and oxygen gas. Okay, which are gases, and oxygen gas and water is always liquid. Clear? So this should be the reaction of electrolysis of water, that is we are breaking down water to give hydrogen and oxygen. Okay, so this reaction can be very beneficial in our current time. Yes, so today we need, what we need, our hospitals require more oxygen for the patients. Okay, so this reaction is already under several studies. If it can be used to produce higher amount of oxygen, it can be used for medical purposes. Okay, so this reaction can have a huge potential in treating our current COVID patients also. Okay, so this is a very important reaction. Now come to our activity. So in this activity, what we are doing, we are taking water in any of the beaker or mug or anything you can possibly find. Okay, so we are taking water over a clean utensil, clean vessel. Okay, so now what we are doing, we are taking two electrodes. Okay, this one and this one, these are called electrodes. So what are electrodes? So electrodes are generally two current conducting rods. Okay, so the electrodes are generally made up of materials which can conduct electricity. Okay, so these are two rods of such material which can conduct electricity. Okay, and these rods are connected to a battery. This is battery. Clear? So what will happen? In one rod will give positive charge, and in another rod will give negative charge. Okay, one rod will be connected to the positive terminal, the another will be connected to the negative terminal. So since this rod can pass electricity, we call them as electrodes. Okay, simply you have to understand this. We are talking electrodes. Electrodes are two rods made up of current conducting materials. Okay, so these two are electrodes. One will be connected to the positive terminal of the battery, the other will be connected to the negative terminal of the battery. Clear? So up to this it is clear. Okay, I am thinking, I am hoping that it is clear. Okay, in case you have doubt, you can anytime contact me. So now I have written about here anode and here cathode. So what does anode means? The electrode which is connected to the positive terminal is known as anode. Okay, and the electrode which is connected to the negative terminal is known as cathode. Clear? So what happens generally, that once we connect this electrode to the battery, what we will get? We will get current over this electrode. Okay, so means current will pass here, and these are the two test tubes. Okay, these are test tubes. What are these? These are test tubes, and which are filled, more than half of the test tube is filled with water. So these test tubes are also filled up to here with water. Clear? So now what you will observe, that once electricity starts flowing over the electrode, we will see that the bubbles of oxygen will be generated here. Okay, and it will come here. Okay, so we will see that bubbles of oxygen from the water will generate over the test tube which is present, the test tube which is present over the anode. Okay, and we will see hydrogen gas, the bubbles of hydrogen gas that will come up in the test tube which is placed over the cathode. Okay, that means over cathode we will get hydrogen gas, over anode we will get oxygen gas. Okay, so in your book it is given to bring a burning candle test which gas is oxygen, which gas is hydrogen. Okay, so why burning candle? Because this is also a reaction that burning candle can be used, or any burning matchstick or any burning object can be used to confirm the presence of hydrogen gas. Okay, so when burning candle will be brought near to the hydrogen gas, so it will make a pop sound. Okay, so from this you can confirm which one is hydrogen gas. Okay, and the other will be, from this reaction you can easily know that other will be oxygen gas. So by this process we can identify that over the anode oxygen gas will be formed, over cathode hydrogen gas will be formed. Okay, so why oxygen is formed over anode, why hydrogen is formed over cathode? So this is again, if you know about formation of ions, which is cation and ion, positive ions and negative ions, then you can easily predict. Okay, so if you need to understand, if you want to understand why oxygen is generated over anode, why hydrogen is generated over cathode, then you can tell me. Okay, you can contact me about this, then I will make a separate video explaining particularly about this. Okay, and I will provide you the answer. Again, one thing you have to note here, that in one test tube I have given the water level little bit higher than the other. Why this so? Because from this reaction you can see, when water 2 molecules of water, when it decomposes, then 2 molecules of hydrogen gas is formed and only 1 molecule of oxygen is formed. Okay, 1 molecule of oxygen is formed. So from this you can know that when water decomposes, we will get double hydrogen than oxygen. Okay, that means the quantity of hydrogen gas will be double than that of oxygen. Okay, so that means hydrogen gas will be formed in more quantity than oxygen. Okay, therefore in one test tube the water level is down than the lower than the other. Okay, so this is electrolysis of water. What is electrolysis of water? That is, we are using electricity to break down the water molecules into hydrogen gas and oxygen gas. Okay, so that is what your activity 1.7 generally describe. Okay, now we'll be looking on some examples. Okay, now we'll be looking on some examples where light is used for the decomposition purpose. Okay, okay, so next we'll be looking at decomposition using light. Okay, so now we are using light as a source of energy to break down any substance. Okay, so in this case we are breaking down silver salts. Okay, salts of silver. That is, one is silver chloride, the other is silver bromide. Okay, so this is silver chloride and this is silver bromide. Okay, and remember one thing, both these reactions, okay, both these reactions are very important for your exam. Okay, in last year in most of the sample paper, question from this and this is common. Why this is important? Because this principle was used in photography, that is black and white photography. Okay, so black and white photography, this particular reaction is the main principle of black and white photography. Although now it is not in use, but this was the main principle which was used in black and white photography. And this is a very common question from decomposition reaction. Okay, so if you do not get other question from decomposition reaction, you may get this. Okay, so generally I have already said this, decomposition reactions are very important for your exam. Already I have said, because more than 1 mark, that is generally 1 mark is already almost fixed, or else you may get more than 1 mark question also from this. Okay, so the first is silver chloride. Okay, and how the question belonging to this reaction is generally given in the exam. In exam you will be asked that when we are heating a particular silver salt which was white in color sunlight, okay, that means we are putting silver chloride, that is, the question will be asked that the white salt of silver is kept in open, that is kept in open means it is kept in sunlight, and after some time we see that the color of the silver salt changes to gray. So the question will be asked, write the equation describing this phenomenon. Okay, so what is happening in that particular scenario, that a white salt of silver, that is silver chloride is white in color, okay, and when we put it, we'll keep it in sunlight, okay. So in your book the diagram is kept where in a cyanide is, what it is kept, silver chloride is kept here in sunlight, okay. So what will happen, after some time, due to this sunlight, this silver chloride will decompose and will decompose to give metallic silver, that is silver metal and chlorine gas, okay. So what will happen, since chlorine is a gas, so gas will go away, okay, it will go away. So what will remain, silver, as the metal silver metal will remain, okay, and the color of silver metal is grayish, okay. So what we will see that when we will look at this reaction occurring, will simply, it will appear to us that a white substance is changing into gray. So what is the chemical reaction? So this is the chemical reaction. So direct question from this reaction is asked, okay. And secondly, I have already told this is silver bromide, okay, and similar reaction will occur and we will get silver which will be gray in color and bromine in its gaseous form, okay. So during photography, when light falls on silver bromide in the film, photography film, we have silver bromide, okay, and when light falls on it, then what happens, the color of silver bromide, it changes, okay, to gray, okay. So from this we get a nice black and white photo, okay. So this is the chemical reaction behind black and white photography. So both the reactions are important for examination purposes, okay. So in this decomposition reaction, we have seen decomposition using heat, decomposition using light, and decomposition using electricity, okay. In all the three types of decomposition reaction, what we are doing, we are providing energy either in the form of heat, either in the form of light or electricity, so that the reaction can take place, okay, so that the reaction can occur. So that means all the decomposition reaction needs energy for the reaction to occur or the reaction to take place. That means all decomposition reactions are endothermic reactions, okay. So what was endothermic reaction? Endothermic reaction was the reaction in which we provide energy so that the reaction can take place, okay. So in all these decomposition reaction, we are providing energy in the form of heat or in the form of electricity or in the form of light. So all decomposition reactions are generally good example of endothermic reaction, okay. So this can be, this point you have to remember that all decomposition reactions are generally endothermic, clear? So I have told this in the starting of this video class as well, okay. So this is all about decomposition reaction. In the next class we will be learning about displacement reaction. So displacement reaction can be of two types, general displacement reaction or double displacement reaction, okay. So we will be learning about that in our next classes, okay. And after that we have oxidation and reduction reaction. In simple, we can call them as redox reactions, okay. So after this, your first chapter will be over, okay. And I also request you, if possible, you please subscribe my channel so that you can get early notification of all the video classes, okay. So you will get whenever I upload any video, it may be related to your class or it may be some supplementary information regarding your courses, okay. So that means some other questions which have already been asked in your previous exams, board exams, so that I may discuss again some videos related to other topics for better understanding. I may give them on my channel. So if you want to get notification about that, so you can subscribe it, okay. So that is optional, so you can subscribe if you want, okay. So thank you.